Sorry, Dr. He, you haven't turned on your microphone, so I can't hear you.
I keep asking Khiết Anh many times, but I muted my mic. I'm sorry, Khiết Anh. Can you hear me now?
Yes, I can hear you now. Thank you.
Okay, good, good. Okay, so how many matrices are here? 2, right? So how can I separate them? Yeah, that's correct, right? So let's say I would have a backward slash, right? And what is it? What else? What else? Let's say, remember that one over here? Coming back to here, you see this, we have something like this one. So if we have an n here, that would put the okay, good. Remember that? Yeah. Pardon? If you have the n here, right? So let's say so let's say what can we do here? Okay, you have the comma, is that correct? No. You have the n and you have the comma. That is not how it works, right? It will not work this. It work this way. Let's see if it works this way. Now let's see if it works this way, right? Now if it works this way, right? Let's see if it works this way. It is not, right? So let's say otherwise we have to use the full the F command and like this one. So I think there is somehow some way over here we put the n on it, right? Let's say like this one. Okay, one way is to do this one. Print B, but let's say this is one way, right? So even if I give a space, it would not print the space unless I tell it so. Here, so now I have to a space in between, right? So basically what you see here is that B and B square are the same, right? So let's say B and B square. So let's say I have B, this is the B, and B times B is the same. So this is known as an idempotent matrix. So in numbers, number 1 is the only number that 1 times 1 is equal to 1. Of course, 0 is another number, but it's not divisible. In matrices, you have many idempotent matrices, right? And our OLS matrices are many of them are idempotent, right? The projection matrix are idempotent. Haha. Now we talk about the inverse, right? We talk about the inverse. The steps to find the inverse, right? Let's say if the inverse is defined, the inverse of matrix A is defined as equal to A times A matrix A to the minus 1, in the sense that A times A to the minus 1 is equal to IN. That is the identity matrix. There are many ways to find. Now, Minh Quân, you are playing with the phone. Minh Quân, how many ways are there to find the inverse of a matrix? Two only? Okay, fine. Two. What are they? So one is the using the determinants. The other is to use the Gauss-Jordan elimination, right? You also have the LU decomposition. You know that one? LU decomposition. So let's say you would decompose a matrix into a lower triangle and an upper triangle. Remember that? Okay, that is the easiest way and the most efficient way of finding the inverse, right? But let's say the most intuitive one is actually the Gaussian methods. So basically, Chi Chung, you know how to inverse a matrix, remember? Okay, yeah, the thing is not very a very confident answer, but I think you should know, right? So let's say to basically to find the inverse of a matrix is the first step is to find the minors, right? Let's say what are the minors? So the minors are, let's say if I have the minor of the position 1 1, then I would cross the first row and the first column have the first minor. Okay, that's the first step. So let's say I would have the second minor by, let's say, for this element here, I would cross the row that contains this and the column. I would have O minus 1, 1, 1 as the next minor. Okay, so this is a 3 by 3, so it's doable by hand. But if I have 100 by 100, I would cross the 100th and the 100th, I would have 99 left. That would be a lot of work, right? But this one is intuitive and can be shed light on many other aspects of mathematics. But let's say for the current purpose, I have all the minors. Get it? I have all the minors so that I can compute the so-called the cofactor matrix. So let's say I would compute the determinants of the determinants of all of the minors. I would get a number, and I would form the cofactor matrix. The matrix C, Cij is defined as equal to minus to the power I plus j, minus 1 to the power I plus j times Mij, right? And then I would have the cofactor matrix. So that's the second step, right? The third step is I will compute the determinants of A. So the determinants of A is very simple. You would take, for example, you can either compute the determinant by row or by column. If by row, you take each and every element of A times the cofactor of A, right? So let's say you take number 1 times C11, okay? Plus number 2 times C12 plus number 3 times C13. That is one way. Or you can do it column wise. You can do the last column. So you take 3 times 3 times 1, 3. Okay? Plus minus 1 times plus 1 times 1 here. Okay, so either way, let's say generally, you can have many ways to compute the determinants of a matrix. And you could expand either by a row or by a column. And the determinant is the same. Right? This is the determinants. Once you have the determinants, you will form the adjoint matrix, right? So let's say the adjoint matrix here is equal to the transpose of the cofactor matrix. And now A to the minus 1 is defined by 1 over the determinants of A times the adjoint of A. Now, so this is very clearly assumption number 2 in our OLS model, in all econometric models. Assumption that the columns of the independent variables cannot be linearly correlated or perfectly collinear. Because if it is perfectly collinear, this one will be 0 immediately. And if it is 0, you cannot compute the inverse. Basically, that's the idea, right? So implicitly here, and I think in the book, they also prove that if a matrix that has a column that is constructed from other columns, its determinant will be 0. Okay? Mathematically, that's so if any row of A is is linearly dependent on the other columns, the determinant of I is 0. So this is one of the reasons why the second assumption is that there will be no perfectly collinear in the independent variable. Now, that is mathematical, right? If you have a variable that is a perfect collinearity, a collinear combination of other variables, the determinants cannot be computed and the inverse cannot be computed. Now, in economic terms, as I often said, if you have a variable that doesn't contain new information, because it can be explained by the other variables, it contains no new information, you should not include it in your regression. That's the idea behind, right? Because if a variable that is a linear combination of other variables, it doesn't bring in any new variation. That's the idea behind. Yeah? Okay, good. Get it, Kylie? Okay. Okay. Now the Gaussian. Now I already done everything. Now you don't play with ChatGPT now. Okay. I already show you the loop. So this is the second. This is one way of computing the inverse. This is the second way. This is second way. So the Gaussian Gauss-Jordan elimination method is that you put the matrix that you want to inverse next to an identity matrix of the same dimension, and you will start eliminating. What do I mean by eliminating? You would first make the first pivot number to be 0, right? Let's say to be 1, and then any number below here that is not 0, you would take the multiple of the first row subtracted, so that until it equals to 0. So if you take the first, you take the third row minus the first row, you will have 0 here. If you take the third row minus the first row, you have to do the same here. You take the third row minus the first row, so it will have a -1 here. See? Now have a look here again. So in order to make a 0 here, lucky me, I have a 0 here. I don't have to do anything, but I have to do the second one. So in order to make this one 0, I would take, say, 1 time of this row minus, let's take this row times a -1 time of this row. It will be 0 here. Now, 2 minus 2 is 0 here, lucky me. 1 minus 3 is -2. But over here, I do the same. So it will be the -1 here. 0 minus 0 is 0, and this is 1. Now, so I have all of them on the left-hand side in this way, and on the lower side here at 0. This one is known as an upper triangle matrix, right? Upper triangle matrix. So an upper triangle matrix is a matrix that everything above the main diagonal can be non-zero, but everything below is 0. Okay, now the next step is that I have to eliminate the element over here also, right? So I would follow the same. In order to make this one 0, I would say, I would take, to make, let's say, to make this one 1, right? Because I need a 1 here, right? To make it an identity. So I would divide row 3, row 2, right? Subtract row 1 from row 3, we get this one. Now we wanted to make it a 1 here, right? Because we make it a 1 here. So we divided row 3 by the -2. You are with me, Tuyền? Yes? Okay, good. So we had a 1 here. Now we want to get rid of this one, right? So we would add row 3 to row 2, add row 3 to row 2, 0, 0, they stay the same, but this one is 0. And now I want to make 0 here, right? So I would say I would subtract, let's say, add row 2 to row 3 to row 2, add row 3 to row 2, I get this one. Now I would subtract 3 times of row 3 from row 1. 3 times of row 3, 3 times of this one, it will be 0 here, right? And finally, I have to subtract 2 times of row 2. Okay, it's row 2 here, 2 times of row 2 here for this one. So I subtract this row by 2 times of this row. I will get an identity, and the same thing over here. The transformation give me this matrix, and this one is the inverse, right? So you keep doing it until when you get an identity here, you get the inverse on the other side. This is the Gauss-Jordan elimination method, right? Program that in Python. See? Do that in Python, and then you become the master of Python. Now do it. Now don't consult ChatGPT. I think Thủy is already doing it. You are not allowed to use ChatGPT now. Okay. Now, so you program this one, right? You see all the steps. This is the algorithm, right? So it's just a step, and then you have to code it. Right? Now, now we try to do something that you can code it, right? Kiết Anh, please code the inverse.
Okay, I'm trying.
Yes. This one, for this one. Okay. Fine. For the any given, it's also fine. Let's say, and for you, an additional task, you turn it into a function that can inverse any matrix. Now it's simple, right? Just if you can write it and then turn it into a function is basically not a big issue. Just check the dimensions of the matrix, right? Now, what can we do? Right? Just write the in order to support you, I want to put the example that when we have to multiply two matrices here, right? You think of it. Right? Let's say for each row, I have to do something. Mình sẽ lên lớp với một hôm nước trà và một hôm cà phê cho tới khi mà không ai được ngủ. Kiểm tra xem bạn học trò cưng ngày xưa bây giờ học hành cũng ngoan không nào. Lâu lắm thì thầy mới lên lớp đúng không? Lâu lắm thầy mới lên lớp. Ok, good đấy. Đúng rồi đấy. Hướng đi ra đúng rồi đấy. Cũng ác nhà thầy mà thầy mà để add được rồi thầy có một cách. Bởi vì là bây giờ thấy cái này thì không thấy cái kia. Bây giờ ví dụ như thầy để cái này các em nhìn này. Bây giờ các em thử thử ngồi mà ngẫm xem, đây là cái bước đi bước làm đúng không? Đó, đúng rồi, đây là cái algorithm đấy, và bên đó là cái ví dụ đã từng làm. Bây giờ cái bước làm của người ta là gì? Người ta phải làm sao mà những cái thằng off diagonal là ta cho nó bằng không, thằng trên diagonal ta cho nó bằng một, đúng không? On diagonal, còn thằng off diagonal ta bắt nó bằng không. Thử viết coi, viết thật dài mà vẫn ra là được. Còn thằng ChatGPT là viết rất là efficient. Đó. Ví dụ như thầy đang nghĩ nhá, việc đầu tiên là ta bắt tất cả bọn nó bằng một, thì ta cứ lấy AI là ta đi mỗi một cái hàng này, ta divide by AI hết, đúng không? Là con nó bằng một luôn, tất cả bằng một. Ta đi từng số một. Nếu mà ai mà khác J mà nó không bằng không thì ta lấy cái giá trị đó, ta lấy trừ của cái giá trị ở đây này nhân với cái dòng đó, rồi trừ trừ cho chính nó, trừ lấy chính nó trừ đi cái giá trị của đó, mà trừ cái giá trị đó mà nhân với lại cái cột đầu tiên, đúng không? Thì cả cái đoạn này bằng không ngay. Đấy, ngẫm đi, như vậy mình tư duy mình sẽ, đúng rồi. Huy bạn đang code ra giấy trước với vào đúng không? Cái algorithm thử làm đi coi các em. Thầy nói thật là những cái bữa học từ bữa đến giờ, bây giờ kết hợp vào cái này là có thể bắt đầu làm nghiên cứu rồi. Còn lại á, cái gì mà trước mà quên á thì đem đọc lại. Với cơ chế nhà trường bây giờ, bạn nào muốn đi làm nghề gõ đầu sinh viên thì cứ cố gắng báo thầy. Không em, cái quá trình làm tiến sĩ là em đã là RTA rồi, đã được nhà trường employ rồi. Dạy chứ, dạy vỡ mặt luôn chứ. Ừ, đứng lớp cùng với ông thầy. TA, khi ở lớp thì là TA, khi ở phòng thì là RA. RA là Research Assistant, một năm cũng phải có publication, một năm cũng phải đứng lớp. À, đó. Mình xem đến đâu rồi. Bây giờ là đang định cách nào để đặt thằng này với thằng này với nhau đúng không? Ừ, nhưng mà đúng rồi, bây giờ em đang nghĩ cách là em phải làm sao em cho hai thằng này đứng vào với nhau đúng không? À nhà, thế là thật là không fair với các em nhỉ. Làm sao để đặt hai thằng đấy đứng vào với nhau đúng không? À, rồi. Thầy nghĩ là không, rất là không unfair, rất là unfair nếu mà thầy không để cái này ra. Đó, bây giờ đây nha, có những cái mà mình oh, I'm sorry, có những cái mà mình phải show thì mới làm được đúng không? Cái này mình chưa biết mà. Đây, có một cái biện pháp này nữa phải biết. Đó, Nếu em có hai cái matrix, bây giờ em có hai cái matrix mà em muốn nó đứng vào với nhau, thì em dùng một cái câu lệnh là câu lệnh stack. Đây. Như này, thầy mà có một ma trận A như thế này rồi, thầy define nó như thế này rồi, đồng ý không? Bây giờ thầy có ma trận I là identity, và thầy muốn làm như cái băng nãy á, thì thầy đề là NP horizontal stack. Horizontal stack là đặt theo hàng ngang, vertical stack là chồng lên nhau. Đấy, như vậy là cái thằng này thành một cái ma trận mới, mà nó gồm chính là cái nào ạ? Chính là cái này. Đây. Đấy, cái horizontal stack ấy, cái thằng này này là nó tạo ra thằng này AI đây, thấy chưa? Rồi, AI đúng không? Bây giờ đầu tiên là bắt tất cả thằng này bằng 1. Ôi, cái này mà cho thi giấy có phải vui không? Chỉ cần invert mấy cái matrix thôi là chấm điểm thoải mái và rất nhanh đúng không? Thôi này, thầy giải đi để đi cái khác. Đi cái khác cũng không chẳng có thời gian. Nhờ. Thế không phải thầy giải đâu mà chat nó giải. Nhưng vấn đề là chúng ta xong quả này là chúng ta phải về là phải nắm ha. Phải nắm, bắt đầu làm quen với phần mềm nào. Đầu tiên là định nghĩa này. Các em nhìn nào. Đầu tiên là định nghĩa cái ma trận A này. After that it define the AI này. This has nothing to do with artificial intelligence. Okay, so AI is the combination of the two matrices. So it just the elegance of Python is that it somehow allows us to imitate the mathematical derivation that we have made here, right? Then it will be once you have the matrix, then you would define n as the length of A, right? So this is the dimension in A, right? So let's say for I in range n, you create a number that is a factor equal to the AI. So that is on the diagonal, right? You would get the AI. And for all the row I in the matrix AI, you divided that row by the factor. So on the diagonal, it will be divided by itself. So it will be 1. Off the diagonal, it will be something you don't know. Now you write a loop, right? For j in range n, again in the number of elements in the column or the rows of A, because we are talking about the inverse of a matrix. So it is a square matrix, right? Of course, we have to generalize inverse later. So if I is not equal to j, that is if it is not on the diagonal, is that correct? Factor is equal to AI, ji, and then aij is equal to aij minus factor times the element ai. Yeah, so if that is the case, finally the inverse is equal to all rows in the AI, and for column it starts from column n to the n. Get it? Okay, so the inverse, if we put the matrix in, you see that in the end, ignore this vertical line. The inverse is from, this is n, right? 1, 2, 3. N is equal to 3. The row from n to the right the column from n to the right, and the row, all rows, but the column only take the n to the right. Is that right? So this is the inverse. So in the language, in Python, it defines the inverse as AI of all rows. Take all rows. And for the column, take that column that is larger than n. When it's right like this one, you take that is larger than n, right? Good. So this is how it inverse a matrix, right? Now, I asked ChatGPT, is this the way that softwares do it? He said no. Because there will be an, let's say, an n factorial operation that we need to do with this method. And with the LU, method, it will be less computationally intensive. So what is the LU method? The LU method is basically when it comes to this form, okay, come to this form, then let's say it will take this form, and it will, this is an upper, and then it will have the E matrix to create the lower. But let's say it is known to be more efficient. You can explore about that. It's quite easy and intuitive. Good. So this is how to create the inverse, right? The inverse. So now, are we going to learn by heart these codes? The answer is no. But are we going to get the intuition? The answer is yes. Getting the intuition means that you must be able to write certain simple code. You understand the steps, but when it becomes more complicated, it will be done by the machine, right? The machine. But we need to truly understand the algorithm behind, right? Algorithm behind. So let's say most of the time we can turn this snippet of code, the whole part here, into a function. And from now on, if you put any matrix in, it would immediately compute the inverse for you, right? So let's say, how can we do that? For example, this is exactly, you would have all kind of functions that you have used so far, especially the estimation, the OLS models. So what do I mean by a function? Let's say this is what I meant, right? Now let's open ChatGPT, right? Okay. Now let's open ChatGPT and say, turn this, let's say turn this into a function so that I can use, I can inverse any matrix. Yeah. Now, so this is what do I mean by a function, right? A function will include, this one is called the, what is it? Computer guy. What is this one? The explanation, or what is it? Documentation, right? Documentation. And here will be the steps, right? So let's say it could just repeat all the steps that we have done so far. Let me show you. Okay. So the first step is to import. What do we need? In this function, sometimes people may not have loaded the library needed. So most of the time in any function, we would load the library that we would need for the sake of being safe, right? So if a module that has been loaded, if you load it again, it doesn't matter, right? So if you load NumPy again, you define Gauss-Jordan inverse A. So let's say, what is the input? How many input do we need in this function? 1, that is A. Okay, some function would need 2 inputs. For example, if you are writing a univariate OLS model, you would need 2 inputs at least. One is the dependent variable, the other is the vector, the matrix of independent variable, right? In this case, we need only 1 input, and the part in green is the documentation. It will explain something, right? For example, here, compute the inverse of a square matrix A using Gauss-Jordan elimination. The parameter you need is A as an array, the square matrix of shape N. It will return the inverse of A. If the problem, when the matrix is not square, it will raise the problem, the value error. Okay. So in this case, how can, now, when a text is in this format, Python will ignore it. So whenever it is, either in front of it there is a slash, right? Let's say that what I mean is this one. If you have something like this one, Python will ignore, right? But here it will ignore only the line that start with this one, only the text that start with this one. In the function like this one, it will ignore everything in the within the 2 triple quotes, right? Triple quotes, right? And then it just forward. Let's say start with A equal to the NP array A. So let's say this one is once more defined as A is the just turn it into number, right? Float. Let's say M and N here is N is the number of rows, M is the number of column. And if N is not equal to M, see, if N is not equal to M, raise the value error, matrix must be square. This is to serve this purpose, right? Okay. See, so the first thing is to check if it is a square matrix. If it is not, I'll give you the warning. This is not a square matrix. Now, if this is not the case, move on. That's the idea, right? Now, I is equal to the identity we know. AI is this one we know, right? And then we repeat the whole set, right? So we are wrapping our calculation in the text that is known as a function, right? And then finally, we extract the inverse and we return the inverse, right? Return inverse here is nothing more than printed. So let's say now I would save. Now I want to save it. I want to save it. Let's say I save it for a quite long name, programming language. First function. Okay, first function. I save it. Okay, so now in my files, you see that I have the, where is it? I should have the first function here, right? File, save as. This is my preparation, right? So let's say send to students. I save it here. And you see that I have the first function here, right? Okay, good. So this is where I store my function, right? So now I need to load. So let's say I go over here. I go over here. I would put it this one. From which file? From this one. Rename from this file. Import which function? The function's name is Gauss-Jordan inverse. Is that correct? Okay. Good. See? Now I will say A, B, or A inverse, or A in. Let's say let's say I have to run this, right? I have to run this. If I don't run it, it will not understand. No, is not a package from it should be able to load, right? From import this one. Now, if we face this problem, right? Let's say I will go out, I go back here and say, I have saved the function as this one. How to load it? Now put the function at in your directory, right? Yeah, I have done it correctly, right? What happened? Pardon? Uh-huh. You mean there should not be this one, right? Let me see if that is correct. Any complaint? Yes, that's correct. So you deserve a cookie. Okay. Now I would put B is equal to Gauss-Jordan inverse A. Okay. Do we have A already? We have already defined A, right? So if I do that, well, let's say for the sake of being complete, I will run the current selection line. So the inverse of A is this one. That is the previous one. Now I want to print B, because B, you see, B is exactly the same, right? Okay, so now this close our section today. So you see that all the time in Python, when we load a function, right? For example, from an example is that when we load function from stat models, we load OLS. So where does it come from? Actually, it is similar to the function that we have done here. They have written a lot of files and they bundle them together into a big library. And when you want to load any function from that, you have to load the exact name that they have coded there, right? So basically, the function that we often use in any software is actually defined in this way. Right? So let's say, so today what we have done, we get used to Python. We do some simple calculation. We learn how to wrap a calculation into a function so that we can do it, we can form a routine that we can do in the future, right? So tomorrow we will truly start with, so let's say today the purpose is to get used to Python. Now, tomorrow will be this topic, right? Tomorrow will be the descriptive statistic in the morning, half of the morning. And then in the afternoon, we will go into manually compute the OOS, okay? Manually compute the OOS and wrap it into a function like the one. So let's say what we have done so far. We wrap it into a function like this and we can inverse any matrix, right? tomorrow we will do all kind of calculation that we need in an ordinary least square model, and we will write a function that from now on, if people give us a dependent variable and a matrix of independent variables, we will be able to give a regression table that is either better or at least look as good as the one that is being presented in Python, right? We will design something, you know, for example, the GFE 2024 function, and then and all kind of innovations that we can can be included. So for now, for today, thank you for the attention, and I'm sorry for the hustle in the morning. I hope that I will have a quiet week next week, and I will try to defend the class. I mean, this is I understand from the development that if I don't take the opportunity today, it could be gone. So sorry for that. And let's say the principle is that the students won't get the priority. Yeah, good. So I hope you have a good rest this evening. You go through all of the slides, only 106 only. Tomorrow I will add about 24. That would make 130. So tomorrow we won't cover them all. So that would be a very intensive day. Okay, very intensive day. So please go through the slides. Why? Because only by understanding the slide like this one, we understand the steps. Then we can code, right? So let's say if we understand the all the aspect of the ordinary least square, we can spend a day on it, and that would be more or less done, right? So tomorrow we will do several things, 2 functions actually. One function is to produce a summary table that you see that as relevant. The other is to produce a regression table. And then on next Monday, we will talk about testing and GLS and the like. Yeah, good. So I look forward to seeing you tomorrow at 9, right? So I will make good tea or coffee. So good. Okay, good tea or coffee. Minh Quân, you deserve a cookie. No, everything I said you said no, right? I will start from here. Let's say 2. If I go 2 by 2, it won't be not enough. So I am sorry. 1, 1 for you, 1 for you, 1 for you. Sorry, I don't have for you. Anh thầy đùa thôi, cô không.
Em mời gia tiên nó hỗ trợ ví dụ có một số cái hoạt động gì đó hay là nó ví dụ như có cái học bổng một trong những cái thông tin bổ ích cái người tự giống như tụi mình thì cái hỗ trợ năm bài viết được năm cái thông tin đó nếu nhiều hơn tham gia trên cái team sắp tới.
Cố gắng đi các em. Bây giờ có một trong những thứ thôi. Bây giờ mỗi bạn này chịu khó kéo cho thầy một người bạn để đi học năm nay. Năm nay lúc đầu á là Đan Thư báo thằng Phú Mỹ đi học là đủ rồi. Không báo được. Không, thầy nói thế này. Tức là gì nhỉ? thực ra thì ngành của mình nó rất là đặc biệt, và ở Việt Nam mình mà đi học toàn thời gian ấy là nó cũng là chưa có thông dụng với mọi người đó. Thế mà các bạn bây giờ mà nghe nói đến học là rất là ngại, nhưng mà thực ra nếu không thì nếu mà học bán thời gian thì làm sao mà chúng ta có thể có những nhà nghiên cứu tốt được. 3 năm nhưng mà đi học đi làm nó chi phối lắm, đi làm chi phối lắm, không học được. 3 năm có thể là 30 năm á. bởi vì khó lắm em ạ, đi làm nó khó lắm. Tức là đi học mà đi học bán thời gian thì thường là người ta tính cái bằng thôi, người ta không tính kiến thức. Thế bạn nào hát hay lên mạng lên trang web của Facebook của ngành hát thật hay để các em đi học không? Ok, hôm nay thầy có còn sao lại còn một cái bánh ở đây nè, để mai cho Khiết Anh nha, Khiết Anh đi mai đi học nha.
Dạ.
Ok rồi, thầy chào nhá, tôi về nghỉ đi, em các anh chị về rồi.
Dạ. Ok, em cảm ơn thầy.
Chào em.